Ah, good morning, madam. Can we be of service?
Well, I just thought maybe I could do with a little fixing up, kind of.
Oh, certainly, madam. We'll be delighted to help you. Now, if you'll just sit down right over here. There, that's right. Now, where would you like to begin? A permanent, perhaps?
Yes, I guess so. My hair is kind of stringy.
Oh, not stringy, madam. It merely needs a little touching up. Our coiffeur will be glad to trim it, shape it, and give it a glorious permanent wave. And, of course, that will include one of our special oil shampoos.
Oh, that sounds real nice.
And, naturally, you'll want a facial massage. In fact, I'd recommend a complete massage if madam has the time.
You mean all over?
Oh, yes, indeed, madam. We can improve your body tone 100%, and in a very few hours, too. You'll have a steam bath, mud bath, and a special thermal bath, followed by a complete massage. It'll do wonders for you.
Well, if you say so.
And, of course, you wouldn't want to stop there.
I wouldn't?
Oh, no, madam. If we can just finish off with a manicure and a pedicure, of course, we can make a new woman of you.
You can? My, that's wonderful. When can you begin?
Right now, madam. If you'll just step this way, our Miss Robinson will take care of you. That's right. Right through this door.
Oh, thanks a lot.
Thank you, madam. Goodbye. Ah, good morning, madam. Can we be of service? A permanent, perhaps? Our coiffeur will be glad to trim it, shape it.
Well, our friend is certainly doing his best to help the ladies improve on their natural resources, which brings us to today's subject for Excursions in Science. You see, Frank Singiser, your science reporter, recently had a talk with Mr. Watson Davis, the director of Science Service and editor of Science Newsletter. Their discussion centered about the problem of the world's future resources. Where do we begin, Frank?
Well, Tup, the great question seems to be whether or not the Earth and its people will survive man's despoiling of our natural resources. We've been too reckless in our use or misuse of our fertile soil, our forests, our coal and oil and metals and other elements.
And does Mr. Davis think the Earth will survive this onslaught?
He thinks there's a good chance that it will, but that man is going to have to change his ways a good deal. As Mr. Davis put it, people themselves are our most valuable resource, provided they don't destroy themselves in a cataclysm of atomic or biological warfare.
That's a big proviso, Frank. How can we best go about avoiding that very possibility?
Education offers the best chance, Tup. We must support the broad education and informing of all people, and thus encourage straight thinking about our common problems. Further than that, we must learn to understand and recognize the emotional, temperamental, and behavior problems that split the world into East and West, that cause fights within our own economic and political structure, that are the basic causes of war. And we need to develop and apply the psychiatric knowledge to keep people saner and more capable of living together without strife.
In other words, the people of the world should be educated for peace.
Right. And it is an extremely difficult problem upon which too little time and money are being spent. After all, a psychological offensive or defensive for peace may prevent atomic bombs from dropping or biological warfare from being waged, and that should be worth a few $billion to the world.
Are there other menaces to mankind that we should mention, Frank?
Yes, taking the long-term view of the situation, we may well be concerned over the possible effects of radiation on the human germplasm. Radiation from X-rays and radioactivity can easily affect future generations by causing mutations that will bring ills or hidden human changes, eventually wiping out some of the great-grandchildren or possibly great-great-grandchildren of those who were sprayed by energy bullets they cannot feel or otherwise sense.
While you're taking that long-term view, Frank, how are we going to make out with regard to such things as fuel, food, and other necessary materials?
Mr. Davis thinks we'll make out all right. He says we won't run out of motor fuel, although it will be made from coal and oil shale rather than simply pumped from the ground. That means, of course, that it will be more expensive than it is now.
Well, I guess I won't sell my car yet, even so. How about the food prospects?
Even better. Artificial photosynthesis, that is, capturing in an industrial plant the energy of the sun by some methods based upon and superior to the way the green leaf does it, should be accomplished within the next decade, he thinks. When this is done, it will be industrially more revolutionary than the release of atomic energy.
Why so, Frank?
Because such man-controlled photosynthesis would give us new methods of food production, making it possible to feed the world without dependence on the process of agriculture. In the face of our ever-growing world population, you can see how important this would be.
It sounds as though the world would be a rather difficult place to live in, Frank.
It certainly will, Tup, and it may not be so pleasant. It's been said that such everyday delicacies as hot dogs and ice cream will not be on the menus in the future.
No, why not?
They are geochemically expensive, and when this country has a population of, say, 1 billion instead of only 150 million, there won't be room in the economy for that kind of food.
Well, what kind of food will we have?
It's a little too early to say exactly, but Mr. Davis told me that food will be made from trees, the wood being turned into edible sugar instead of being used to build houses. Instead of meat and eggs, our proteins will come from plants, yeasts, and fish.
Yeah, suppose I want a steak.
Well, Tup, it may be possible to build synthetic amino acids and make them into the equivalent of beefsteak. Just how they'll taste is anybody's guess.
How about fats, Frank? We need those in our diet.
Edible fats can be made from coal. In fact, the Germans developed such a product during the recent war.
Well, I guess we'll be fed, after a fashion at least. But what are we going to wear?
There's really no problem there, Tup. We're already using a lot of clothing materials made from the cellulose of trees, as well as from coal, air, and water.
You said a few minutes ago that there would be no fuel shortage, but I've been wondering about vehicles that use the fuel. How will we be fixed for automobiles, trucks, and so forth?
We may well worry about the steel from which those articles are made, and it's quite possible that in the future, steel will be leased for specific uses instead of sold outright. We are also using up our supplies of copper, zinc, tungsten, lead, silver, and mercury. They'll have to be replaced by more plentiful materials such as aluminum and magnesium, and by less well-known metals such as titanium and molybdenum.
How about houses, Frank? Will they have to be changed too?
Almost undoubtedly. They're not likely to contain scarce materials such as iron or steel or wood or even plastics. Most likely they'll be made of clay or earthenware, which is, after all, about what an all-brick house is today.
Now, how would you sum up the whole future outlook, Frank?
Well, Tup, Mr. Davis said that the first step is for all of us to realize that there is danger in our future. Not enough is being done basically to save the world's resources from exhaustion. If it is to be saved, we must all cultivate a far-sighted attitude, concerned with the world situation several decades or perhaps even 200 or 300 years from now. We need something that might be called a World Survival Inquiry, or some kind of international commission for the exploration of unknowns, or something of that sort. In some way, we must recognize and prepare to deal with the shortage of some resources that the future must inevitably bring.
Many thanks, Frank, for bringing to us this interesting discussion of the world's future resources as outlined by Mr. Watson Davis, Director of Science Service, Washington, D.C. Friends, if you would like a copy of the paper dealing with today's subject, it's yours for the asking. Just drop a postcard or letter to Excursions in Science in care of this station and ask for Science Paper 397. That's Science Paper 397. Now, Frank, let's get along to answering some of these questions our listeners have sent in. Our first question is from a gentleman who wants to know about the salt-like coating that sometimes appears on brick buildings and how it can be removed.
That salt-like coating is usually calcium carbonate, which is the same as limestone, though it may occasionally be calcium sulfate, gypsum, depending on the chemical nature of the mortar and bricks. If it's calcium carbonate, you may wash the bricks off with a dilute solution of hydrochloric acid and follow that by a thorough rinsing with fresh water. However, this is not without some risk because the acid will tend to dissolve the mortar between the bricks, which might cause a weakening of the structure or other trouble.
What about removing the calcium sulfate?
There isn't any convenient way of doing that, Tup.
Then it looks as though our friend may be stuck with those white streaks. And now for another question. This one comes from a lady who asks, when was DDT discovered?
Although this valuable and potent insect killer has come into widespread use only during the past decade, it was first developed way back in 1874 by a German chemistry student.
But why did it take so long before we started using it?
Mainly because its insect-killing properties were not discovered until the 1930s. A Swiss chemist by the name of Paul Muller was responsible for that discovery. The first reports of its efficiency as an insecticide reached this country in 1939. The armed forces quickly took it up then, and the rest is history.
And now, Frank, we have another one of those famous scientific questions. A listener writes, if a gun went off when there was no one around, would there be any sound?
It all depends on what is meant by sound. When a gun goes off, it produces a series of air waves, much the same as those produced when a pebble is dropped in a pond. When these air waves strike the eardrum, we experience the sensation of sound. Sometimes when people speak of sound, they mean just the air waves. In that case, there would definitely be a sound. However, sound is also considered to be the sensation produced when these air waves strike the eardrum. Under that interpretation, if there were no one around, there wouldn't be any sound. However, if a gun goes off, there's usually someone present to pull the trigger, and he certainly would hear the sound of the gun.
Frank, while we're on the subject of guns, here's another question about them. Our correspondent wants to know how the barrel of a rifle is blued or blackened.
This is achieved by first grinding, machining, or polishing the surface of the barrel until it is clean, and then heating it until an iron oxide film of the right thickness is formed.
What causes the change of color, Frank?
Light waves reflected from the top of the film interfere with those from the bottom, eliminating certain wavelengths, and thus giving a color made up of those that are left. A number of different colors can be obtained depending on the thickness of the film.
Our next question seems to come from a sleepy listener, Frank.
How so, Tup?
He wants to know why we yawn.
Well, yawning in humans and higher animals is a reflex action made up of many components. According to one theory, slight deficiency of oxygen in the bloodstream and in the brain is responsible for starting the yawn. Though it may be associated with sleepiness, it does not necessarily indicate a need for sleep.
Maybe our correspondent just thinks he's sleepy then.
Maybe.
And now here's one from a listener who is apparently using his spare time to paint his house. He wants to know if he can use kerosene to thin the paint instead of linseed oil or turpentine.
It would probably not be very satisfactory, Tup, since kerosene contains compounds which would remain in the paint film for a considerable time, softening and weakening it. The linseed oil in the paint is the vehicle. On exposure to air, it absorbs oxygen and is converted to a hard, insoluble structure which holds together the particles of pigment and binds the film to the wood. The thinner reduces the viscosity of the mixture, and when turpentine is used, may actually aid the oxidation process.
I think we have time for one more question, Frank, so here it is. Our listener wants to know how the moon controls the tides.
Tides are caused by the gravitational attraction of the moon and also the sun. The water on the side of the earth toward the moon, being nearest that body, is pulled most and bulges out above the mean water level. The water on the far side of the earth from the moon is pulled least, even less than the body of the earth itself. The earth is pulled away from that water, leaving another bulge in that side. As the earth revolves each day, these bulges go past, causing high tides, and between the bulges, then, are low tides. Local conditions and the pull of the sun, which has a tide-raising force about half of that of the moon, cause considerable complication to this simple picture.
And with that, Frank, we better wind up today's program. First, though, I want to remind our friends that they have a standing invitation to drop us a line anytime they want the answer to some scientific question. We'll call on the General Electric Research Laboratory or some other equally reputable scientific organization for the necessary information and enclose that in a personal reply. All you need do is mail your request to Excursions in Science, care of this station, and please be sure to include your name and address. Also, I want to remind you that the number on today's science paper is 397. Now, this is Howard Tupper
And Frank Singiser.
saying goodbye until the next Excursions in Science program.